Hey, this video is for everybody, and I want to talk about how you might be able to add up all the positive powers of 2 and somehow get a negative number. As a warm-up, let's add all the powers of 1/2, like 1/2, 1/4, 1/8. I've drawn visually what's going on. We have a whole pizza, and then half a pizza, and then a quarter. I hope you can visually see that this sum seems to be converging to 2. The other thing we can do is look at the partial sums where we add like the first 3, 4, or 5 terms and see if those are approaching something, which is just another way of thinking about this picture here. More generally, this is called a geometric series, and if r is between -1 and 1, the sum of all the powers will converge to 1 over 1 minus r. You can see I have some examples here like 1/2 and 1/5. These infinite sums are going to converge to 2 and 5/4. But if we plug in a number outside that range, we get nonsense, right? 1 plus 2 plus 4, there's no way that's converging to -1. Look at those partial sums, right? It's 3 and then 7 and 15 and 31. It's getting bigger and bigger, definitely not close to -1. But believe it or not, there is an area of math where this is true, and I want to show the motivation, which I think is pretty reasonable. It's something called the two-adic topology, and we start with all the whole numbers, positive and negative, and we agree that 0 should have the smallest absolute value, of course, and we just make this note that any number is 0 if and only if it's divisible by every power of 2. And then this is where things get a little weird. We're going to say that since having all the powers of 2 as a factor should mean you're 0, we're going to say you're small if you have a lot of factors of 2. Now, I'm not going to get into the specifics, but roughly, since 2 to the 10th or 1024 has 10 factors of 2, it should be smaller, in fact, a lot smaller than the number 30, which only has 1 factor of 2. So if having lots of factors of 2 means you're close to 0, then the sequence of powers of 2 should be converging to 0. Those numbers are getting closer and closer to 0 because they have more and more factors of 2. And if we take that sequence and we just subtract 1 from everything, then that should mean the sequence 0, 1, 3, 7, etc. should be converging to 0 minus 1, or -1. And if I get out of the way, those are actually the numbers we saw as our partial sums earlier. So in this weird way where having lots of powers of 2 makes you small, this red equation is actually true. Believe it or not, using things like this is actually really useful in algebra and geometry. It's at the heart of something called number theory. Let me know your thoughts in the comments.